All right, so to kick off the video, here's in the back warehouse. We got this this motorcycle brought in. Now these are also new, and I haven't talked about this yet. These new targets from Creaform, they can be used with any of their scanners, but they're a new multifaceted base. People have been doing like printing these forever, but now the software, if you can see there, actually recognizes them as a feature, as a positioning feature, and it'll remove them. It has all the advantages of the positioning targets. So here with the AccuKit, I've set up our scale bars, and I'm shooting all the targets, be it reflective single targets or those faceted targets ahead of time. And what I'm basically doing here is a photogrammetry process. So we do have a standalone photogrammetry system as well, but the HandySCAN Plus with the AccuKit really brings it all together. We shoot all the targets in, the scale bars, we let it process. It gives us a very tight volume, and then we switch right over to the scanning surface. So now, yeah, at this point, we're basically 3D scanning everything that we can on the motorcycle. There's lots of little nooks and crannies. So, you know, when you get to something like this, you definitely have to work that scanner around. But that really, when you start to do parts like this versus like an arm-based scanner or a tripod-based system where you take an individual shots, you know, I can get this whole thing done in 5 to 10 minutes, maybe a little more than that, depending on how picky I am, where it would take me hours to do this with other systems. If you have to reposition your scanner every single time you need a new line of sight to take a shot, it just takes forever. I've done it. We've done it here. We did it for years. And this is way more flexible. And then not having to manage an arm. You can see there, everything's going through a cable. You know, we've got a ton of data to process. So the most fluid way to do that and keep the scanner light, you know, not have onboard power, not have onboard processing, is to still run a cable. But we've got one cable that goes to the computer, and that's all we're limited by. So we can completely work around whatever we need to. It's great. We don't have to worry about linkage arms, anything like that. So there you can see more of those faceted targets. They're pretty neat. You just throw them up all over the part. They're magnetic. So it works great for anything magnetic, automotive, something like that. If you need to put adhesive back on them for if you're doing aluminum, things like that, you can do that. All right. So that's the, you know, again, we're done with the scan. So that's all I have to do. I've scanned that thing completely 100% in one session. This is VX Model. So I've taken the motorcycle and brought it into Creaform's VX Model module, which is a reverse engineering. Again, additional module on top of the scanner. But what it does, it has all the different features that you would generally need for reverse engineering. This is a really cool function, this pipe fit wizard. So you see me playing with this slider tolerance, so you can select an area and then you can expand the tolerance of like how far out or close it needs to look for that same feature. And you see I'm pulling these center lines of these pipes. So we're going to easily do sweeps on these complicated curves. Straight pipes, you can just extract cylinder sections. So here I'm extracting actual cylindrical features. Again, may have grabbed a little too much on the initial selection. I simply pull that tolerance down and basically pull it down until it only grabs the feature that we want. And that's why I say VX Model, again, a very easy to teach program. When I'm looking at training, people catch on to this program very quickly. If I want to do something like get the pattern, the whole pattern to this brake hub here, what I like to do is I like to separate the mesh. So I selected that area, I've copied it to separate it, and I'm going to add a plane to that face. Okay, you can see there, fit a plane right up to it. Get the normal view, and then there's a few ways you can go about this. Number one, I like this circle extraction method. It's called edge selection, and it looks for edges like the interior edge of the circle, and it fits circles to that. Now you can preset the diameter, or if the diameter is really close to something, you've got 20 or 30 circles like this, you can set the diameter to the first one, maybe from kind of a weird number, round it to the one that makes sense, and then it'll keep that through all the rest of them. The other thing you can do is a silhouette range, which is actually, I kind of talked past it, but we basically took a cross section, a 3D cross section of the entire profile of that projected into the plane. So instead of getting full circles, we're getting a profile that we can send to our modeling software to sketch on, essentially make it a 3D sketch. Here we're going to add, if I want to get some angles of pipe, that's fairly common, doing pipe bending. If you want to get some angles, do some quick checks, you can certainly do it in VX Inspect. You can also do it here. Not only can we extract the features, so I've just put some cylindrical sections in all those, but we do have some basic measurement tools, so we can throw an angle between the axis of these two cylinders and get what that real angle is. So if you do have a real quick check you want to do on one, you need to compensate for some spring back, you can just do it if you got VX Model as well. If you want a nice repeatable one that has a report attached to it, that's where you go to inspect. Okay, but yeah, a few more features there. Some mesh cleanup tools. I'm doing kind of a real quick overview of all the different tools, but we got a hole fill that's very, very effective. It's gotten very impressive. On this, you can see the glass is pretty noisy. You might have noticed that on the helmet too, where the glass looked pretty noisy. It's because to the scanner, there's no definite surface there. This scanner does great on it, and then you can clean it up and make it super smooth with that sandpaper tool. It's really nice. You can see that the mirrors are missing. They're super reflective, so they're not going to come out, right? So what we can do, especially if we want to make this like a complete mesh, is we can adjust the boundary of it to be a perfect circle. So you see there, we get this nice clean boundary, and we do the same thing for the other. And then now that it's a clean boundary, we can do another hole fill. So I don't want to do a flat fill on a boundary that's jagged, because you end up with a surface that looks really funny. But now we can do a hole fill, and instead of it being like a contour fill, we can make it a flat fill. And since that circle boundary is perfectly flat, when we click on it, it'll make a very, very clean fill very quickly. So there we go. So if you need to put that in there, maybe you're doing some repair for 3D printing or whatnot, or just getting a scan watertight, we've got all the tools, all the mesh cleanup tools in here as well that you need. So very nice software, one user interface with all the tools up there, and it has tools that you need for like 95% of what you'd ever need to do. Here, if you want to do some sort of, here I want to do like a revolve feature. So we're not physically modeling in here necessarily, but we can pull features that we need to model, and then we're sending those to our CAD program. So if you got SolidWorks or something like that. So here, what I'm doing is I'm extracting a center of this, basically this revolve feature, by extracting a cylinder on it. I'm gonna tie it to the coordinate system to make sure it's like totally square, so when I reverse engineer it, the angles and stuff make sense. And then I'm gonna utilize that center axis to cut a cross section. And now I've got a cross section, just like with the circles earlier on the brake hub. I've got this 3D sketch profile that I can send to my modeling software, and I can basically trace it and remake that revolve and that modeled part in my, parametrically in my modeling software. So last thing I want to show on the bike, there's a ton of stuff you can do in here, but just to give a gloss over a few different options, is if I want to do a complex surface of this, of the fuel tank, again, I want to clean up the edge, regardless of what surface I do. I like to clean the edges. I don't want a really nasty, jagged edge. And then I like to remove features that aren't going to be included in the surface. So the fuel cap that's going to be like a secondary model feature. So I don't want it messing up my clean surface. What I'll do is I'll delete it. And now I've got my hole fill here. Just like before, we're going to fit a circle to it to make a nice clean edge to fill. And we're going to hole fill that. So you wouldn't even be able to tell it was there, right? That looks amazing. You can't even tell if there was a cap there. So there's some different features. We got single fit features. There's a clean mesh tool. It's like a one-click, check over to make sure the mesh is good. But when it comes to surfacing, so you can do a bunch of things. You can cut cross sections and send them over and make like a parametric surface on the other end, let's say in your CAD program, or you can fit a very, very clean, nice nerd surface here. And it just depends on what your end result is, like how you can model, your capabilities of your manufacturing, a few different reasons why you do one or the other. But yeah, we've got a very nice tool that does a clean surface on on anything you need. And then you can transfer that right to SolidWorks. In this case, we can go to Fusion, we can go to Creo, Inventor, and depending on other applications that you use as far as reverse engineering, we can expand upon that.